An extraordinary celestial event is unfolding, captivating astronomers worldwide. Betelgeuse, the magnificent red supergiant that graces Orion's shoulder, is undergoing a remarkable transformation. This stellar giant, renowned for its brilliant red hue, has been a fixture of the winter night sky for centuries, mesmerizing observers from ancient civilizations to modern-day stargazers. What makes this transformation so extraordinary is not only the internal changes within the star but also the sheer scale and rapid pace at which they are occurring. Betelgeuse, a star vastly larger than our Sun, is showcasing the dynamic and unpredictable nature of the universe. Its characteristic radiant glow has intensified beyond expectations, surging to an incredible 50% brighter than usual. Imagine a light bulb suddenly shining twice as brightly. This is Betelgeuse's astonishing cosmic spectacle. At the start of this year, Betelgeuse held the prestigious title of the 10th brightest star in the night sky. Its steady luminosity was a familiar beacon of stability. However, this unexpected surge in brightness has catapulted it to the 7th position, sparking excitement and curiosity in the astronomical community. Observations and studies are underway to unravel the mechanisms driving this dramatic change. Betelgeuse, a colossal star in the late stages of its life, is so enormous that if placed at the center of our solar system, it would extend nearly to Jupiter's orbit. Eventually, it will undergo a cataclysmic collapse, resulting in a supernova explosion that could leave behind either a neutron star or a black hole. The anticipation surrounding Betelgeuse's supernova stems from the fact that it promises to be a spectacular event. Located approximately 650 light-years away, humanity is ideally positioned to witness this cosmic drama unfold. When the star ultimately explodes, it will create a dazzling display of light. Initially, there will be a burst of neutrinos sweeping across Earth, detectable by observatories worldwide. Following this, as high-energy photons escape from the expanding cloud of stellar debris, Betelgeuse will rapidly brighten over the course of a week, reaching up to 100,000 times its normal luminosity. Depending on the explosion's intensity, this cosmic beacon could rival the brightness of a full moon and even be visible during daylight hours, casting distinctive shadows at night. This awe-inspiring event could last for an extended period, providing an unparalleled opportunity for detailed observations and potentially groundbreaking discoveries. While supernovae have historically been associated with omens of calamity, we can take solace in the fact that Betelgeuse is safely distant, ensuring no adverse effects on Earth. To fully comprehend the enigma of Betelgeuse, we must revisit late 2019, when peculiar phenomena began to manifest. During this period, the red supergiant exhibited significant dimming, a change noticeable even to the naked eye. Observations using the Very Large Telescope revealed that Betelgeuse appeared mostly symmetrical, but its photosphere, the star's outermost visible layer, showed signs of major disturbances. Researchers observed that the photosphere was expanding at a steady rate of approximately 8 kilometers per second for much of the year until mid-November 2019, at which point the outward motion began to slow. By mid-November, the flow of material from Betelgeuse ceased, prompting astronomers to capture new optical images of the star. These revealed two striking anomalies. First, a darkened region in the star's southern hemisphere created a stark contrast with earlier images from the year, and second, the star's surface temperature dropped by about 80 Kelvin between late January and mid-February 2020. Betelgeuse's brightness reached an unprecedented low during this period. However, over the following months, the star gradually regained its luminosity, eventually returning to its typical brilliance. This raised the question: what had happened to Betelgeuse? The evidence strongly suggested that the star experienced a massive and unprecedented event known as a surface mass ejection, SME. This phenomenon bears similarities to coronal mass ejections, CMEs, observed on the Sun. To better understand an SME, imagine a volcanic eruption on a stellar scale. Material from the star's interior is propelled outward, creating shock waves in its atmosphere. Over time, this material forms particles and dust, partially obscuring the star and causing it to appear dimmer. In Betelgeuse's case, the SME ejected a staggering amount of mass, 400 billion times greater than typical events on other stars or CMEs, equivalent to several times the mass of the Moon, expelled at incredible speeds. Scientists noted that such an enormous mass ejection from a star's surface had never been observed before. The event provided a rare opportunity for direct observation and analysis of surface features using the Hubble telescope, offering a real-time glimpse into the evolution of a dying star. The SME had a profound impact on Betelgeuse, causing it to lose a significant amount of mass in a single event. It was as though the star had violently shed its outer layers and was now in the process of gradual recovery. Following this dimming event, Betelgeuse's behavior changed. Previously, the star exhibited a regular pulsation cycle of approximately 400 days, but this has now shifted to a longer 600-day cycle. As a semi-regular variable star, Betelgeuse naturally undergoes periodic changes in brightness due to variations in its size and temperature. However, the recent changes mark a departure from its historical patterns. These pulsations are believed to occur in two primary modes. The shorter 400-day cycle is attributed to fundamental pulsations, while the longer 5.6-year cycle arises from more complex processes within the star. Betelgeuse's transformation continues to fascinate astronomers, offering a unique window into the life and eventual death of a massive star. Astronomers have been closely observing Betelgeuse, a red supergiant star, uncovering critical insights into the final stages of massive star evolution. Once believed to follow predictable patterns, the star's variability has presented new surprises, particularly through changes in its pulsation periods and episodes of dramatic dimming. One of the most remarkable events in recent years was Betelgeuse's dimming episode, which began in late 2019 and lasted into mid-2020. This event caught astronomers off guard as the star's brightness significantly decreased, becoming noticeable not only to the naked eye but also through precise measurements using advanced telescopes. Such occurrences are rare for a star of Betelgeuse's magnitude, prompting intensive studies to uncover the underlying causes. Theories behind the dimming. Researchers have proposed several explanations for these dimming events. One leading hypothesis suggests the star ejected material from its surface, possibly due to convective processes deep within its interior. These processes, akin to massive bubbles of hot gas rising through the star's layers, can disrupt its typical pulsations and expel stellar material into space. Known as surface mass ejections, SMEs, these phenomena are common in stars, but the scale and impact observed in Betelgeuse make it a unique case for study. Changes in pulsation patterns. Following the dimming, astronomers also noted alterations in Betelgeuse's pulsation patterns. Its usual 400-day cycle appeared disrupted and was replaced by a shorter 200-day cycle. This shift hints at significant turbulence within the star's structure, potentially signaling ongoing instabilities that could lead to dramatic future events, including a potential supernova. Supernova. A spectacular possibility. Supernova explosions are among the universe's most energetic events, marking the end of massive stars' lives with a dazzling display of light and energy. While Betelgeuse's recent behavior has sparked speculation about an imminent supernova, astronomers caution that predicting such events with certainty is challenging. The timing of a supernova depends on internal processes, including the fusion of heavier elements in the star's core and its eventual collapse under gravity. At an estimated 8 to 8.5 million years old, Betelgeuse is in the advanced stages of its life. Having exhausted its hydrogen fuel, it is now fusing helium in its core, a process that will eventually produce heavier elements like iron. The accumulation of iron will signal the end of stable nuclear fusion, triggering a catastrophic core collapse and possibly a supernova explosion. If Betelgeuse were to undergo a supernova, its proximity to Earth, approximately 650 light-years away, would make it a spectacular cosmic event. The explosion would temporarily outshine its entire host galaxy, casting shadows on Earth and generating detectable neutrinos and high-energy photons across the universe. Historical and cultural significance. The fascination with Betelgeuse's potential supernova is not just scientific but also cultural and historical. Throughout history, supernovae have been observed and documented, often leaving lasting impressions on civilizations. For example, the famous supernova of 1054, which created the Crab Nebula, was recorded by Chinese astronomers and remains a subject of modern study. In contemporary times, advancements in observational astronomy enable scientists to monitor Betelgeuse with unprecedented precision. Telescopes like the Hubble Space Telescope and ground-based observatories continuously track the star's variability, refining models and predictions about its future evolution. A star of symbolic importance. Beyond its scientific significance, Betelgeuse holds cultural and symbolic value across civilizations. Its name, derived from Arabic origins, has been interpreted in various ways throughout history. In Arabic astronomy, Betelgeuse was often associated with parts of the human body, reflecting ancient perspectives on celestial objects. Its prominence in the night sky has inspired stories, art, and philosophical musings about the nature of stars and their role in the universe. The road ahead. Looking forward, astronomers will continue to monitor Betelgeuse closely, anticipating further changes in its brightness, pulsation, and structure. The star's evolution offers a rare opportunity to witness firsthand the dynamics of massive stars nearing the end of their life cycles. Each observation and discovery enhances our understanding of stellar evolution, supernova physics, and the broader implications for the fate of stars and galaxies. As technological capabilities improve and new generations of telescopes come online, scientists will gain even deeper insights into Betelgeuse's behavior and its ultimate destiny. Whether it undergoes a supernova in the near future or continues to surprise us with its variability, Betelgeuse remains a captivating object of study and a testament to the dynamic, ever-changing nature of the universe. For years, the origins of Betelgeuse's peculiar behavior have remained elusive. In a recent research study, scientists utilized computational simulations to gain deeper insights into the unfolding events. They proposed that an unusually hot gas bubble, resembling an immense and extraordinary air pocket, emerged from within the star. Such events are not uncommon in massive stars, as turbulent convection in their outer layers drives the movement and mixing of material, much like a pot of boiling soup. As this hot gas bubble ascended and broke through Betelgeuse's surface, it triggered the ejection of stellar material and disrupted the star's typical pulsation pattern. The surface expanded while its interior contracted, resulting in a shift from the star's usual 400-day pulsation period to a new 200-day rhythm. Astronomers anticipate that Betelgeuse's pulsations will gradually stabilize over the next 5 to 10 years, eventually returning to its original cycle. Regarding the possibility of Betelgeuse undergoing a supernova, experts estimate it could occur any time within the next 10,000 to 100,000 years. Based on factors like its color, brightness, size, and estimated age, scientists suggest Betelgeuse is currently in the early stages of fusing helium into carbon. This fusion process will continue through stages involving oxygen, silicon, and eventually iron, at which point the star's core will collapse under its gravitational pull, leading to a catastrophic explosion. Since Betelgeuse is 650 light-years away, any supernova event occurring now would only become visible to us after 650 years due to the speed of light. Thus, it is highly unlikely we will witness the star's dramatic demise during our lifetimes. What makes Betelgeuse unique is that its surface is visible, unlike most stars. This visibility provides astronomers with a rare opportunity to study how massive stars behave as they age, including phenomena like these remarkable mass ejections. Recently, astronomers made an unexpected discovery: a star devouring its own planet 12,000 light-years away in the constellation Aquila. Such findings add to the intrigue of Betelgeuse, a star whose name and position in the night sky have captivated humanity for centuries. Its significance extends beyond scientific interest, influencing pop culture and mythology around the globe. Betelgeuse's name has roots in the Arabic language, originally translated as the armpit of the giant. Some scholars argue it may refer instead to a hand or shoulder. These physical associations are reflected in various cultural interpretations, often tied to human or animal figures in myths and legends. In ancient Japan, it symbolized a severed limb, while in Brazil, it was seen as a turtle's or caiman's leg. In Sanskrit, Betelgeuse translates to the moist one, linked to the Ardra lunar mansion and the storm god Rudra in Hindu astrology. Throughout history, Betelgeuse has played a central role in cultural practices and traditions. In Macedonian lore, it symbolized domesticated animals and agricultural life, while in regions like North Baffin Island and the Melville Peninsula, its appearance signaled the arrival of spring and longer days. Its prominence in the Orion constellation, as the star marking Orion's right shoulder, has further solidified its cultural and astronomical importance. As one of the brightest stars in the sky, ranking 11th in luminosity, Betelgeuse's reddish glow and variability have fascinated and inspired artists, writers, and filmmakers for centuries. Known scientifically as Betelgeuse, it continues to captivate astronomers and enthusiasts alike with its recent transformations and the potential for a future supernova explosion. Positioned prominently in the constellation Orion, Betelgeuse has been a celestial icon for millennia. Its vibrant red hue and dynamic behavior remain a source of wonder, reflecting the mysteries of the universe and humanity's enduring fascination with the stars.